Hello and welcome to this new task script tutorial. We will be using version 2.6.7, which was just built, and we will address the ladder diagram design. So in this tutorial we will start fresh with one empty project declared through our wizard, and then we will define a ladder diagram, then we will compile it, upload on the junction box and run it, and see the results of the junction box directly here on the studio. So let's get started. Let's activate the wizard. I have here on my desktop a junction box with single Ethernet, so I will create an empty project for this kind of junction box. Here we are. So notice that now we have meaningful names for IOs. This means input bit port 1 pin 4, then port 1 pin 2, then port 1 pin 5. Let's recall that this kind of junction box has 4 input ports with 3 inputs each, so 12 input bits in total. Then we have likewise 8 output bit channels, 2 per port, so they are OB1 pin 4, port 1 pin 2, port 2 pin 4, and so on and so forth. We will not be using word data for this, no? So we will get rid of all this stuff and also these system variables. So here is our starting template. Notice that the wizard has already allocated for us the main task, and inside the main task it has allocated one initial step. But in this case, since we need to work, we wish to work with ladder diagram, we will get rid of this step, which is flow, and we will allocate and we will define a ladder diagram initial step like this. And this is all what we need. Notice that we know that this is a ladder diagram because of this symbol. Then we can also change its name, like LD1, for example. Okay. One last thing at this level when we talk about variables. We will need one variable of type keep bit, which is kept, and we will call like loop. I will let you know just now why. Well, because I'm planning for this tutorial to write a simple ladder diagram which just blinks the output LEDs of our junction box one at a time in sequence, and will loop through this sequence. So I will show you the use of this loop variable. So recall that this is a bit keep variable, which means that this variable keeps its value until it is being set to another value. And this is one important type of variables that we have in TaskScript. The other important type is bit temp, which means that this variable only stores its value for one scan, and then it is set to 0 at the beginning of each and every scan. But now let's forget about that variable. We will need a keep variable. So let's go inside our step and let's start writing a ladder diagram. So we are here with our empty sheet. We insert rang, which is number 1, of course, and we will start adding a contact, and we will drive a coil. So our contact will be the loop variable, which is initially 0. and this is why we will use it as normally closed. Sorry, want loop, and we will drive directly output bit 1, 4, which is our first bit. Then we will add a rung, and we will define a contact here, normally open. Then we will add a timer because we want some delay. This is a T on of 1000. We could change if we like it, but we will keep it as it is. Our timing will be 1 second, and this contact will be driven by OB14. So as soon as OB1 will turn on, which is just immediately because this variable is false at the beginning, we will start counting, and at the end of this count we will drive OB1.2, which is the second input, and then we just copy. We will duplicate this rung below, and we change this variable to OB1.2, and this will drive OB2.4, which is the next in the sequence, and so on and so forth. So let's duplicate again and again. We will need 8 of them because we want to lit all the variables. 6, 7, 8. And let's go and change. So this is what we want to do. Yes, this is correct. So this is OB2.4. We will drive OB2.2, which is next in the sequence. Then OB2_2. We will drive OB3_4, and so on. Very simple. Three, 4, 3, 2, 3, 2, 4, 4, and then 4, 4 will lit 4, 2, and then after 1 second we will, when OB42, which is the last LED, we will turn on key 0, which is loop. Okay. And this will make the whole chain to reset, because this will turn to off, and then since we have this turn off, this will turn off, and all of them will turn off, and we will start counting again and again. So let me show how it goes. Let's save it. Let's provide the name, like tutorial LD, for example. Okay. Now we will compile, no errors, and so I will upload junction box. Before doing this, let's recall that we need to make sure that everything is correct for the discovery. So in this case, I have an old junction box with one Ethernet port, which is USB here. Network interface is Ethernet, so everything is okay. So I can upload. It's uploaded, and let's start. So now you cannot see what happens because I see directly the LEDs which lit on the junction box, but right now I will turn on the visualization of the state, which is here, and well, by the way, I see that here there is an error, and so I can change it. So this is 2_2. So 1,4 goes to 1,2, 1,2, 2,4, 2,4, 2,2. Well, it looks like I have one rung which I don't need it, so I will just delete. So let's see in this case if it is okay. 4, 3, 3 to 4, 3 to 3 to. Yes, I think that it is better. So let's compile again and upload again. Okay, uploaded again, started. Okay, so the LED sequence looks fine on my junction box, but now I want to show it here on the TaskScript Studio. So here I just make a snapshot in a precise moment, but now I set it to continuous. So now we will see that it is being refreshed periodically, and so we will see that it runs correctly. So I think that we can stop this tutorial here, and I will record just afterwards another tutorial in which I will show how the results of this simple ladder diagram can be seen on the HMI. So thank you, and thanks for watching.